Hi, I'm Jennifer Schopf. I'm at TAC in the University of Texas at Austin. And what I'm going to be talking about this morning is a little bit of a different talk. It's a case study for an open source project called Netsage. This is growing out of a request from the Open Source Program Office, User Advisory Group. They wanted to understand more about how projects did their lifespan from initial idea through their hurdles to what could be termed a successful project. So this is a little bit different than the normal talks that I give about Netsage, because I'm going to be focusing on it as a case study of the project. You know, how did we start? Where did the collaboration come from? How did it grow? What were challenges we faced with? What were some inflection points? So I'll start with who am I and why you should listen to anything I have to say about open source development. I have a PhD in computer science from UC San Diego. I worked with Fran Berman, where we worked on very pragmatic problems. In my case, it was cluster scheduling and what users really wanted. From there, I did what many PhDs do, and I thought, hey, I'm going to be a tenure track faculty member. I went to Northwestern. I ran a team there for several years, and then I got recruited over to the Globus team. Globus at the time was the software, open source software, to work with different computers, to be able to make jobs, to be able to do file transfers. They wanted to have a scheduler. I had a scheduling background, but it turns out in order to schedule, you have to have data. They didn't have any data, so I actually wound up building a measurement monitoring tool called MDS. I also, as part of the leadership of that team, put in place the process for the Globus toolkit, which at the time had 6 or 7 pieces, to start getting outside contributions. So what did they have to do in terms of contact points? What did the code need to look like? What did the documentation need to look like? How was the help desk going to work? And all of these features to have an open source project actually take outside contributions. I should say, since I left the team in 2008, they've got a very different model now. We were fully grant funded at the time. Now it's an open source, but a paid for model. And so it's a very different structure than it was then. But I was deeply invested in trying to take this tool and get outside contributions and understand how we could support them. I was also part of a tool called Persona, which at the time was very nascent, looking at testing small messages between sites. Persona is now the tool used by all research and education networks and almost every science project to understand how data flows in our networks behaving correctly at a really low level. But that was another open source project that I was working with at the time. 2008 to 2012, I worked at the National Science Foundation, where I was a program officer for pragmatic software and pragmatic networking. I really pushed open source requirements and viewing open source software as an entity. People had already talked about referencing data sets. I pushed really hard about referencing software. I helped define the NSF data management plan policy, in part because I'd also done work like that when I lived in the UK the previous couple of years, which is a whole other story. And I gave a whole bunch of talks about referencing software, the way we did data. And this is a slide that I found in one of my old decks where I was talking about software sustainability and how software was free. It wasn't free as in beer or free as in speech. It was free as in puppy. The pre-picture, these are Great Pyrenees puppies. The post picture was my dog Benjamin at the time, 125 pounds of love and hair. Puppies, you have long-term costs. They need care and attention eventually. You know, they're going to lose their charm after growing up. I mean, how many nights was it, Benjamin? You have to come inside. I know you want to protect me in the yard from the falling leaves. You have to come inside. This was not very charming. The puppies are cute. The dogs need a lot of kibble. So open source software is free to you, but it needs care and feeding and sustainability. And that's something I pushed really hard on when I was at NSF and tried to get the community to understand and respect as well. When I left NSF, I went to Indiana University. I ran an international networks team there, but had a chance to build this measurement and monitoring tool called Netsage, which I'm going to be talking about jointly with the team at LBL, Lawrence Berkeley Lab, and ESNet, and the University of Hawaii. In 2022, I started here at TAC, brought Netsage with me. And in 2023, I was asked to help open an open source development, open source program office. I'm sorry, I should say program, not development, for UT Austin. We're now working on one for UT System. So, Netsage. I give 3-hour tutorials on Netsage. I'm going to cover in about 6 slides here. It is a measurement and monitoring tool for networks. It helps you see patterns of behavior for large-scale data movement. It was originally funded by NSF as this collaboration. Currently gets about 4,000 unique visitors a year on our dashboards. These are people we don't know, which is kind of cool. I think that's a great measure of success for an open source project when it's used by people you've never heard of in places you don't know anything about. It's focused on use cases. So unlike a lot of measurement and monitoring tools built by engineers for engineers, we came at it from a very different point of view. What are the kinds of questions people are asking of the data? How can we show you this? And what data do we need to move forward with that? So this is the basic architecture. Every measurement and monitoring tool basically looks like this. It pulls some data in, it does some munging to make it sensible, puts it in an archive, then you display the data. I said it was built around questions. We see, what is this interesting pattern? Why is this transfer so slow? Why did this transfer, between Singapore and Taiwan go through Los Angeles? These are all real. These happen every day. So understanding what's going on and how we can improve it, this is the tool you use. We're improving our data movement because it improves the time to science. Because the bottom line here, and when I ran a network program, I had to keep reminding people, the goal wasn't to build fancy networks. The goal here isn't to build a super cool tool. The tool is to help end users and end user science. So that is the goal that we have to keep in mind as we go forward. We've got all these snazzy dashboards, top talkers over time, all sorts of things. And if you want to know more about this, we've got a bunch of talks, which I only realized this morning weren't actually linked to the website. They're going to get there on Monday, including a tutorial we did at Taxter just earlier this week, and a couple lunch and learns by my team talking about some of the new features we've put in the last few months. So this talk's not about Netsage, it's about the project and how we develop the project over time. So how did it start? Officially, you saw the slide I said, it started as an NSF-funded collaboration between IU, LBL, and University of Hawaii Manoa. NSF wanted to understand what was going on with their international network investments. So unlike high performance computing investments where you have to apply for time, you say this, I'm a geoscientist studying hydrology and I need this many cycles to do this kind of stuff and here's my grant number. Networks just happen. Your data transfers over the network. You, as a scientist, don't know which network it's on, don't know why it's on that network, don't have any information about it at all. It just happens. And quite frankly, NSF wanted to know who was using their $7 million a year investment in international networks to try to get some of the other divisions to help support them. High performance computing, 30% of the time used by high-end physics. So the physics division actually helps support those investments. International networks, they get used by everybody. Nobody knew who. So we got a grant in 2015 called Netsage, an open privacy-aware network measurement analysis and visualization service. And it was a requirement for the international networks at that time to work with us and share data with us so that NSF could figure out some of these issues. And so the engineers could see what was going on. And so end users could understand what was going on with their data movement. That's the official story. How it really started was a friendship. Brian Tierney, who is a network guru at the time, he was at LBL and ESNet. Now he consults for me, among other people. He's semi-retired, drummer in New Orleans. Jason Lee, who is at University of Hawaii, but then was at University of Illinois, Chicago, visualization master. The three of us were at a computer networking workshop. I don't remember what the workshop name was. I just remember being in a big room of about 150 people, mostly network engineers. And they were saying, scientists want a tool so that they can show where their network data is moving. So what is the route it's taking? And the scientists, the chemists want to go in and change the route that it's taking. So if you're going from, network routing is really complicated. And there's a whole bunch of esoteric algorithms that figure out how your network, your data is routed through a bigger network. So if I transferred data from, say, here to Indiana University, it would go from a TAC network to a UT-OSPO network, to a UT system network, to a state of Texas network called Learn. From there on the internet to probably up to Chicago. From Chicago, it would then route down to Indianapolis, where it would get onto a network called ILITE for the state of Indiana. It would go into the IU Bloomington campus, and from there to whatever machine I had told it. Doesn't have to. It could instead get routed through Atlanta. There are various reasons why networks are routed different ways. All these network engineers were like, well, scientists want to make these decisions. And we disagreed. And we were pretty vocal in our little corner saying, no, we disagree. You know, look at FedEx. I don't know why my package from Chicago to Indianapolis goes through Memphis, Tennessee. FedEx does. That's the right way for it to go. And it gets to me in 12 hours. That's all I care about. I don't want Google Maps. I want a FedEx map or an Amazon portal at the time. So this is 2013-ish, 14-ish. I just want to know when my data is going to get there. And if it's running slow, I want to know why, and I want some, to know, hey, this isn't quite right. Who should I talk to fix this? They didn't want it routed themselves because the routing is super hard. I'm not going to tell FedEx, don't send my package through Memphis, send it this way instead. No, that's dumb. They know more about this than I do. Network engineers are always going to know more about networks than scientists. So this, we argued and went and drank a whole bunch of adult beverages after this and had conversations. So we really liked this idea, and we kept talking about it every time we bump into each other at meetings. I wound up at Indiana University. Jason got a new job at Hawaii. We still wanted to work together in our new roles. We've been talking, he was starting up in Hawaii just as I was moving from DC to Indiana, and the differences of living in those two places was pretty stark at the time. And an NSF opportunity came up for this international network. So we started with a basic idea and a friendship in order to make this happen. So that's where a lot of projects, I think, start. They don't start with someone thinking, I'm going to save the world. They start with, these are the people I like. These are people I want to do a project with and figure out how we can work together going forward. We are still friends. The main development is now just a TAC, but we still play together on these ideas, and we still bounce things off of each other. And when we do new versions, I still say, hey, what do you think of this, and how could we do this better? So I was asked to talk about the initial team structure. So initially, we had 3 different institutions. We kind of had to break up who was going to specialize in what. Indiana University had something called the Global NOC. So I was leveraging them. They had a couple data sources, especially something called SNMP data, doesn't matter, and how they had their own backends to get that. And they were getting that from a number of different domestic networks. So they had something we could build off of that they had already built, and it had been running for a couple of years. The Lawrence Berkeley guys were focused on some of the network use cases. Brian was a really great network engineer, but he talked to a lot of the DOE, Department of Energy Science guys. And University of Hawaii, Jason had these amazing grad students who were really creative in visualizations. Because we quickly realized that, to answer these questions, because we were working with Jason and we came up with this, what are the questions we want to answer? You could have a whole bunch of different visualizations to answer any question. So we would do a whole bunch of which visualization is better. Let's just use both. And you can actually see that kind of echoed down into our use cases today. So, this really got shaped by the team and how we were doing this. Other groups would have built this very differently. And as I'll talk in a little bit, at one point, we actually broke off, a piece of it broke off, and it's turned into a very different tool, but with the same core infrastructure. So why open source? It was open source because NSF made this a requirement, and NSF made this a requirement because when I was an NSF program officer, I made it a requirement. Great. What license did we pick and why? I honestly, none of us can remember what the original licenses were. What we think happened, as I talked to them in prepping this talk, is, the LBL guys used whatever their local one was. The IU guys used something slightly different. Hawaii had what they used locally. I think one was BSD, one was Apache. We're not sure about the third one, but we do know that none of them were GPL related. The copyright issue that I had seen when I was a Globus guy, and we were trying to include other things. So for those of you who don't know, if a piece of your code is in a GPL related license, that means that the entire code is covered under that license. In most interpretations, we didn't want that. We knew that we needed to have pieces that were separate and could get included in other things easily without that viral nature. So now we're under Apache 2.0. We moved, when all the pieces got moved to TAC, we unified the licensing, and we picked Apache 2.0 because Persona, which, you know, from when I had been originally involved in it at our Western, is now a huge project with, you know, a team of 12 people working on it. They use Apache 2.0. And there's a lot of crossover in terms of the developers and the folks we've been talking to from that. So this made sense for us to choose what was the license used by the greater community that we were part of. So the initial code was a little bit weird. Sorry, I just noticed I have a thing. Get rid of that. All right. So we had some code that IU had been using for the back end. UH for the visualization piece had another project called Sage, not related to Netsage, that they had for front end, and we kind of tied them together. But it was really bespoke. There were pieces that were developed, they were all in-house. We would collect the full data set, send it from the different points because the international networks had been told you have to do this. Luckily, we ran a couple of them, so we had guinea pigs that were willing because they were us. And, you know, collected it all at IU and shared it. So this was my initial architecture. This black line here, so this piece ran on their system, just the data collections. All of this ran at IU, okay? Because that was the easiest way to do it at the time. We did have the archive kind of bifurcated. So all of the data with full IP addresses and everything went into one place. We ran all the extra tags, put it over to another archive. So we could say this archive has no IP addresses. This one did though. So that matters for later. So we deployed these little sensors in a bunch of different places. And we could display this SNMP data with graphs where darker colors meant more data was flowing. We had top talker kind of data for the different sites. Sorry, these are really blurry because I found screenshots from a talk in 2016. In 2017, we added flow data, which was really cool because that actually told you institute to institute, not just the volume. So SNMP data is kind of like having a camera on a stoplight and counting how many cars are going through. Where flow data is actually like having some information on the cars themselves, and it tells you where they start and stop and how fast it took them to get from point A to point B. We do a lot of car analogies in the networking space. But so we expanded to flow data in 2017, which was really cool. But then we had to do a big demo for our program officer, November of 2017 at the Supercomputing Conference. And as we were prepping for the demo, we found a number of things that we needed to tweak and change, right? This wasn't production software yet. This was a research project that was kind of getting known in the community and kind of getting picked up a few places, but it was very much us on the fly. We didn't really have release numbers. We didn't really have coding standards. We were, 8 people kind of who got it together every week and were pushing together a piece of research. And at this conference, we realized there were only 2 people who could change the front-end visualization code. And they were both grad students. And one of them was in Hawaii, and we were on the East Coast. This was a huge problem. And at that meeting, we realized, okay, we need to turn a corner here. We have been a research project for the last couple of years. We need to turn into at least semi-production or academic production code to support this, because more people are using this. People we don't know have started to use this and ask us questions. We need to formalize our process. And part of formalizing the process was changing how we did the front end so more people had access to it, not just grad students in Hawaii. So we started looking at trade-offs. This is one of the big lessons we learned over this project, is this trade-off between building something yourself bespoke and using somebody else's tool, which is pretty close. When we started this in 2015, there weren't a lot of graphic front ends. Grafana did exist, but nobody was really using it yet. There were several others we considered. So we started by using our own code in part because it gave us control. Right, we could control release schedules, we could control compatibility, we had manpower to do it, we thought, and we could build off of existing things and get something up pretty quickly because we had experience doing this, we could move. But we realized that that wasn't going to scale for us, that we needed to start taking advantage of other people's software, other people that all they did was this piece, so that we could do the creative pieces we wanted to do. So someone else has the maintenance version of making sure all the security patches are in place, and all we have to do is upgrade our version. We don't have to figure out the patch. There's a bigger community that we can talk to and learn from and say, hey, we're trying to do this. What have you done? You know, having outside people be able to say, oh yeah, I did something similar and this is the trick that I used. Invaluable. We found a really friendly collaborator in the Grafana team, to the point where some of our developers quickly became part of their inner circle. And when the GrafanaCon happens, you know, the folks who are now at LBL often give talks there and say, hey, here's a new piece that I added into their code. However, we lost control. We had to accept their upgrades and what they were doing, knowing that when they did a new version, occasionally that would break things. However, we did this mostly for sustainability. We knew that we needed to have a broader base to build off of. We needed other people contributing things that we didn't have time to do everything. So we spent 3 months researching it and chose Grafana, as I've mentioned, in part because it had multiple backends as a possibility. It was growing in popularity in the community, and we could contribute visualization widgets to it because through the Hawaii team, we had all of these really innovative ways to visualize the data. And Grafana was completely open to accepting our open source widgets from us. And then, you know, we could actually say, hey, we've got it this far. We'd also like something that looks like this. And they would actually think about that and put it somewhere on their development cycle. So this was really cool. This shift allowed us to expand our developer pool. So we shifted things. The Indiana team continued to manage the back-end resources. But the Hawaii team shifted from having to support all of the front end and everything to being able to do more creative researchy things, which was more appropriate for grad students anyway. And the LBL team kind of stepped up in terms of making the front ends look alike, use the tools properly, and leverage each other. So by relying on this third-party team in Grafana, we could do more than the sum of our parts, even knowing we didn't have as much control. Talked about a lot of that already, but it really was a trade-off. And this came up a couple of years later. One of the things we did in our early dashboards is to navigate between them. We had this little in the corner, this little N that would turn to an S, go back and forth, and it would spin. Or we call it our spinny S or our spinny N. And when you clicked on it, the list of questions would come down, and so you could really easily go to another dashboard. You know, so this was how we navigated between the dashboards. However, this is non-standard for how Grafana uses dashboards. They want you to have a much more Unix-like structure for your dashboards. And at some point, they stopped supporting how we did our spinny S. And by then, the graduate student who had built it had left Hawaii. So we were going to have to rebuild it from scratch, which was going to take significant effort from somebody to try to figure out some kind of weird hack to make this happen. And we basically stalled in updating Grafana for about a year and a half, trying to figure out what were we going to do. And we finally just bit the bullet and said, we're going to have to go with their style of dashboards, even though it's not as intuitive for our users. We kind of put in as many hints about how to use this as we could. I still don't think it is as collaborative or useful or intuitive, but we had to move forward with the Grafana versions to keep up with security patches and other features that we wanted to be able to use going forward. So this was a trade-off. By using Grafana, we lost our really cool navigator, but on the other hand, we gained a whole lot of functionality. We did other shifts away from the bespoke code. When we started, we had one set of dashboards for the International Research Network Connections IRNC project. And so, we would have an SNMP dashboard, and we'd have a bandwidth top talkers dashboard, and we'd have a persona, dashboard, all of them, whatever, IRNC, Netsage.global / whatever. But then we started working with a number of domestic schools or domestic networks in the US, Front Range Gigapop and Scenic in California and SOX in Georgia. And they all had these different dashboards. So the deployment got really hard. And in 2018, the front end guy said, hey, we're going to start using this tool called WYSI. A lot of people are using it in this space, simplifies what we're doing. This is great. We all agreed, yeah, we need to simplify how we're doing this. This has gotten to a point where we need some tool. We don't want to create our own tool if something's out there. Spot on. Unfortunately, the pandemic happened, and 3 years later, the developers stopped developing. And so we no longer had WYSI. And again, had the same thing happen where if we upgraded to another version of Grafana, the old version of WYSI that was no longer getting updated was no longer compatible. So we had to figure something out. But we were lucky that, in building these collaborations, we had help. One of the things that had happened during that time frame is one of the main Netsage developers at IU, Ed Bayless, went to ESNet, Department of Energy, part of ELSA. They were building a new internal measurement and monitoring system for engineers. They had wound up taking the code base for Netsage, forking it, renaming it Stardust, and changing a lot of the infrastructure because their use cases were really different. They wanted a more engineering focus. They didn't want the question focus, but they wanted all of the internal data gathering. They wanted the visualizations we had already had, and they had a huge team to do this. So we had stayed in touch as they had done this work, and we were still sharing things back and forth. They ran into this WYSI problem as well because they were still using it too. They solved our problem for us because we had another collaborator in the space with a very similar code base. They built something called the Grafana Dash and Grab, and that is the tool that we now use to do our dashboard propagation. So this is great. This is another open source tool that's out there. Somebody else is supporting it. Now there's a half a dozen tools that do this, but at the time there really wasn't a lot of choice. I think we would still pick this in part because we have a collaborative history with this team. So if we run into a problem, we also have somebody we can call up and say, hey, can you help us with this? And when you run into a problem with anything you've gotten from us, we'll help you. We've leveraged them in other ways as well. So when I made the decision to come to TAC, and it was decided that the core development of Netsage would come with me, we needed to move away from the bespoke code that we had used from the global NOC, part of IU. So that's what we had been using for our SNMP data. They had been supporting our backend Elastic Stack in a very, with some internally focused pieces added to it. And so again, we went to the LBL guys and said, hey, what are you doing for SNMP ingest? And what they hadn't really released yet, it's kind of in alpha beta form. We said, well, what if we took it and helped you finish debugging it so you could release that as its own little thing? And then we'll use it internally. And that's what we did for SNMP data. In the meanwhile, that team had also hired up some of the grad students from University of Hawaii. And so we managed to get additional visualizations from that team that we are now using in Netsage. So there's been some really nice back and forth because we had this collaborative action to begin with. So the lesson here is, collaborators are worth their weight in gold. You should not try to go on your own if you have an option, which isn't to say that you do everything that the other guy does. You make different choices based on what you need. But if you can find other people working in the area, if you can find people that you can leverage off of, or just call up and say, hey, we ran into this. Have you seen that before? This is worth its weight. I got asked to talk about some unexpected challenges. A big one, early on in 2016, the General Data Protection Regulation was launched in the EU. This is the wide-ranging security legislation across the European Union. It says personal data must be kept private. Pretty simple. However, we had flow data, which had IP addresses in it, and they were de-identified. We dropped the low order bits, both for IPv4 and IPv6. But it wasn't clear if this counted as personal data or not. Some people said, no, that identifies a machine, not a person. Don't worry about it. Some people said, yes, that could identify my laptop. It is a deal. Nobody had agreement. Nobody could tell us, high level, can we do this or not? So I spent 3 months talking to lawyers in Europe. I went to several extra conferences. I got introductions from my international networking partners there, introduced me to their lawyers, introduced me to other folks, and we came up with the agreement that, yes, IP data was personally identifiable information, despite what NSF said, but it was okay to de-identify it. You did not have to anonymize it. So the difference is you can de-identify data. You could, if you have enough stuff, figure out where it came from. Anonymized, you can't. Dropping the low order bits, I know what university it came from. I know the subnet, so I might know the department, but I don't know the actual machine. This was agreed that we could share. The lawyers I had talked to other lawyers, the regional networks there came to an agreement. And this, because we've had this agreement with them, this continues to be one of the strengths of our project and the use of it internationally. And even in the US, when we run into security, people are like, whoa, I don't know if you can share subnet data. I can say, well, we've passed muster with GDPR, Again, it was a collaborator to let us do this. It was the fact that we had spent the previous years working with these international networking folks, showing that this was a useful tool and trying to find a way through this path that everybody wanted an answer to. We just didn't know quite the right way to get there. They helped us navigate the politics. And when we have new partners come on, we say, I understand your concern. Talk to this guy from Germany. Talk to this chief security officer of this network. They will tell you why they think this is okay. So we didn't just have to do this on our own. We had a community that was backing us up saying, hey, this is all right. Another security challenge. Security is hard. Our initial deployments, right? This black line was here, right? So all of the data went to IU. And we were told, I'm not thrilled with IU having my full IP address. I want to have control of that. And so we said, well, okay, we could do that. We could containerize the whole ingest pipeline. So this would be something you'd run on your local machine. Because we can containerize it, we can run it on a virtual machine anywhere. You would put your stuff to this container. The container would then share de-identified data to our backend. We could do that. And we knew this was possible to do for like 1.5 years, but it was pretty far down in our stack because it's like, oh, this is going to be a lot of work. The con is anytime we update that, we're going to have somebody locally do the updates. That's a big hassle. What means we're going to have to be way more careful about how that gets deployed and the documentation around the ingest pipeline, which, up to that point was kind of a little loose and easy because it was only deployed internally. And I don't even know that we had full documentation, because the two guys that did it just knew how to do it. But, eventually we did it. A guy named James Deaton then at the Great Plains Network, now at Internet 2, really pushed for this. And it was huge. The number of Netsage deployments tripled in the next year because we had this feature. So the lesson here is listen to the people who aren't in your team who are trying to use your tool. This, internal to the tool, we didn't see this as a deal. But externally it was, and one guy made it clear it was. Turns out it was for a lot of people, they just hadn't said it or didn't know how to verbalize it. This was so much of an improvement that even with the added headache of, we've got to have somebody else deal with the client end when we do upgrades, when we moved to TAC, we moved all of the deployments to this style. We no longer have any of the old style deployments where people send things to us and then we do this ingest here, which has simplified our life in many ways, made a couple of things harder. So when we do push out new ingest pipeline updates, we're gonna babysit guys over the next 3 weeks. Hey, have you done this yet? Hey, have you done this yet? Hey, do you want to get on a Zoom thing and we'll walk you through the 3 commands that anyone should be able to do, but we're happy to walk you through it. So we keep that in mind. All right, that's to talk about how we've supported the Netsage project. I mentioned originally we were supported through a 5-6 year grant from the National Science Foundation to do this for international networks. During that time, I actually got another domestic grant called the Engagement Performance Operations Center, or EPIC, and that's how we grew some of the domestic deployments, but that was just a little tiny piece of that grant. That grant had a whole bunch of other things. We tried to garner support within international networks. We had hoped that NSF for the next round, because every 5-6 years they do these international networks, we'd hope that the next round they would include a network monitoring component, an independent network monitoring component, because for the first time, the data wasn't self-reported. One of the things we had learned over the previous 5 years, that self-reported data and the independent data didn't always line up, which was fascinating for NSF, but for budgetary reasons, that didn't happen. So in the next round of international networks, there was no specialized funding for a network monitoring tool. However, there was a requirement that each of the individual networks do something. And 2 of the 5 awardees had contracted with the team to keep this running for them. The others did bits and pieces of other things. Some of them we actually kept things running because it was easy enough. Some of them, have done their own way. We considered a bunch of different models. The one that we really had hoped might work when I was at IU was a pay-for-services model. IU had a big network support operation called the Global NOC, the Global Network Operations Center. And they worked with many of the regional networks and campus networks in the US to help run the network, to make sure that data was flowing and routers were kept up to date and all of these things. So we thought, well, maybe you could offer Netsage as an add-on service. It's fairly independent. The lift would be fairly small. If you got 6, 8, 10 of these, that would pay for the new development. We could do this, right? And we were talking about how to do this. And I got recruited to TAC. And I said, what now? Yeah, we're not going to do that. So most of the development team came with me. We've tried a couple times since then saying, hey, it's open source. You could still use it. They've been talking about developing their own flow tool. I think it's going on about 10 years now. They still don't have one. In part, it never bubbled up to a priority for them. In part, that team was very much in the mindset of, if we don't build it, it's not real. And they did not like the trade-off of somebody else is supporting this. We're reliant on another team. And they've got history in that. For network engineering tools, it's understandable. In our case, if we had had that mindset, we would have died. So it's just a different way to do this. So going back to support. One of the pieces of my startup agreement with TAC was TAC acknowledging that this tool, Netsage, was extremely useful to a broad community. We didn't yet have the leadership class computing facility, but Dan was real sure we were going to get it. And part of the leadership class computing facility, which is a giant machine and all the associated services, is making sure the community can actually move data to TAC, LCCF, and making sure that the time to science is what it should be. So he said, this makes sense as part of our community support. We will continue to support this. And right now, the main development for this is supported from the LCCF. We also have direct funding from a large project called Access. That's the support layer over the various NSF funded machines. They're required to share data, not just HPC data, but also networking data. So that also helps support the team. And it was written into the solicitation because NSF realized this is an important part of the community. So what's now and next? The primary development is here at TAC, although we work very closely with the LBL team and occasionally swap things back. We're deployed by 6 regional networks. They're supported by my team, about 10 international networks still supported by the IU folk. Got about 4,000 unique visitors yearly. The development is slowing down. We've gotten to a point where things are pretty stable. We have the functionality we're asked for. We've added in a bunch of things in the last 2 years. For example, we're pulling in Globus data now, which is fabulous. So all the Globus transfers, we worked a deal with the Globus team and we get that data from them on a daily basis. And we can show you internationally all of the transfers that use that tool. We've added in resource tags, so you can say, not just that the data comes to TAC, but it goes to Lone Star or Corral or Ranger, not Ranger, Stampede 3, sorry. We've added in communities. So for example, Learn, the state of Texas network, wanted to know everybody who is using Globus across Learn. We can show you that now. It's just a couple of flags. We've considered adding in some additional visualizations for Stardust. That's probably where we're going to go next. And we give presentations and take use cases from the community. But the development, which had started at probably about 4 or 5 FTEs, is now down to about a half an FTE and a half an FTE kind of supporting all the deployments out there. It's in steady state. So the lesson learned here is build something the community needs. Because the community was using this and the community recognized the value in this, we had a broad enough user base that they advocated for us. They advocated that it should be part of Access. They advocated so that when I came to TAC, it was recognized this is something that would help the team. This is something that would help, and we all know that Dan Scanzione is trying to take over the world. He viewed this as a piece that might help him do that. So, we had to deal with replacing PIs as people shifted, with people leaving their institution, with people getting pregnant and taking time off, developing families. We had a very close developer, Dan Doyle, pass away, which had a big impact in one part of the project. And we had to deal with the PIs with shifting priorities. So Jason Lee at University of Hawaii was handed a huge new portfolio just as we were looking at recompeting the project. If we had continued, if there had been a second IRNC Netsage, it would have been really challenging for him to be as involved as he had been. We had to deal with tech that didn't actually do what we thought it did. There's a whole saga about, we had planned to use a tool called Bro to do deep packet information and additional flow data. Turns out Bro doesn't work for asymmetric paths. So when your data goes out and it doesn't come back the same way. And it also turns out that 97% of international flows have asymmetric paths. We knew that from a couple other tools. We thought Bro was okay with it. It turns out Bro just didn't barf like everybody else. It just kept running and didn't collect any data. Took us 6 months to figure that one out. And we had built a bunch of reliance on that as a tool. So, that was a shock. The funding agencies changed needs, the teams and the collaborators changed, all of this kind of shifted over time, and you just had to kind of find a path through it to manage it. The big lessons we learned were finding collaborators that you want to work with. You want to find, this started with the 3 of us that were friends, drinking adult beverages in a bar, saying, oh God, I don't want to tell my network data where to go. That's what scientist have you ever talked to that wants to do that? Except for a couple hydrogen physicists who we think aren't quite stable anyway. there are trade-offs to be evaluated between building your own and using other people's components. We leaned into using other people's stuff, especially as the project matured, for sustainability and for broader manpower, so that we could concentrate on the pieces that were needed to be tuned for our use, not the general tools. We really wanted to listen to users who were part of the original team. We've always tried to do a fair amount of outreach on this tool to find out how other people are using it, what other use cases they came up with. There were a couple years in there where every time we would do a demo to a conference audience, people would ask us new questions. People would want to see the data in a different way. And so that really changed how we were developing it, in part because we knew that we, even though, we had a fairly diverse group. We had a faculty member, we had a network engineer, and we had whatever I am this week. We knew we needed a broad audience and a diverse set of people talking to us about their needs and their wants for this. Because we knew for longevity, we needed to build something that the community needed. To this date, when I review NSF proposals, my bar for broader impacts is, does anybody outside your lab care that you have done this? So I would urge that for anyone thinking about developing a broader open source project. The success isn't, I've got an outside contribution or I've managed to have this part of somebody else's thing. The success is someone you don't know at a place that you don't know has reached out to you because they're having an issue. Or they want to tell you, hey, because you have this, I was able to make this argument, and that's helped me in this way. So you want to have the strangers, you want to have the community really help rise you up. So, in conclusion, you can try it out. This is just the TAC page. A lot of really cool data there. It's a little weird because one endpoint for everything is TAC because that's the TAC exit router. If you want to see more of a network, you could try learn.netsage.io or socks.netsage.io. It's a neat tool. Every time I do a demo, I learn something new about what's going on with how people are moving data, and we see ways that we can help people. We had a lot of unexpected challenges. We had some we expected. We expected people to move on and retire. We expected tools to kind of grade. We didn't expect GDPR. We didn't expect how much containerization changed how we use our tool. And try to build a useful community. The community will repay you. It is worth it to put your stuff out there and to have people throw tomatoes at you. Here's my contact information. And I think we got about 5-10 minutes for questions. Thank you. I don't know if there's anything. Oh, there's a chat online. But that's probably just
there's chat. Let's see.
We may not have questions. Yeah.
That's a good question. In my work, I have to think a lot about what is the impact of open source, and it's really hard to pin down. But it's one of these things. It's like it's obvious when you see it, and this obviously has a lot of impact. So could you? How would you define that? Like, can you what's your view of what impact of open source?
How would we show the impact of this tool? So we had a couple different ways that we would do that when we were doing a lot of NSF reporting. One of the big ones is this: how many unique visitors a year? I can show you. So in this case, because we had both people using the tool and we had the data collected by the tool, we kind of we try to show impact in both ways. So we try to show that we had a depth of knowledge. So how many regional networks used it? How many routers and SNMP collections we were doing? So we tried to do counts because impact, especially from a funding agency, you need a hard number count. We had unique users. We had, how many different widgets we had, and we had contributed up or contributed down. The fuzzier ones was we would get, I don't know the right way to word it. Thank you messages. We get users to write us little blurbs of, because I had Netsage, you know, somebody noticed I did a 7-day SCP transfer. I didn't know that wasn't a good thing to do. They reached out to my institution, who could drill down and see that I was the person doing it, and told me about Globus. And now what had taken me 13 days to transfer my files, I can do in a day and a half. You know, so user stories to try to show. The impact we'd like to be able to do, and we haven't managed to, in part because NSF, to get NSF funding for certain software programs, you have to show how you've impacted a specific science domain. So in this case, how would we speed up data transfers specific to a science domain? We actually tag science domains and we work with the community on that. That's a whole nother talk. We've never been able to package that up in an acceptable way for NSF to say, yes, you're helping this particular science domain. What we do is we help a whole lot of engineers and infrastructure people. So it's a little bit harder. And I don't know that, you know, so wearing my open source program office hat, Michael Shensky and his team have come up with this list of all the software in a GitHub repository that mentions UT-OSPO. And the metrics they use are things like, you know, how many people are watching this, how many contributors, how, you know, how recently was it touched, those kinds of things. On most of those metrics, Netsage doesn't show up very well, you know, because now the dev team is down to a handful. You know, pieces of it don't even show up as UT-OSPO because it was developed by other collaborators or by us before we came to TAC. So, you know, people don't really download it directly from GitHub, you know, because we package things up for them better in another way. We've talked about, you know, putting the packages in GitHub so that we kind of have those counts. It's kind of, you know, our users don't want that. They just want it on a web page somewhere to grab it. So it's a challenge.
Yeah.
You know, and we're open to, if somebody comes up with a good idea of how to show impact, we're all ears. But you're right, that's a hard time. Any other questions or comments?
I have a question about, it's maybe a technical Netsage question. Does it, can you use it to evaluate performance between nested virtualization layers? So for example, yeah, I mean, you know, I now have containers inside, with virtual networks talking to other containers on other nodes that are inside VM networks.
So we really can't.
Yeah. Okay.
Because in part, one of the interesting security problems we dealt with is, you know, when we're first talking about deploying something and we say we de-identify the IP addresses and people are like, oh, is that enough? We're not sure if that's enough, when, you know, basically they generally come down to, okay, that's enough. And then as soon as we show them a dashboard, they say, well, but what IP address was that?
Yeah.
We're like, we just spent 6 weeks talking to you about how we don't have a full IP address.
Yeah.
We never have a full IP address. So not only can I not show you what's happening within a machine, I can't even tell you what's happening within a subnet.
Right.
I can tell you maybe a little bit about what's happening in a subnet if the data goes out and comes back in, which it shouldn't do. But sometimes, so I can tell you if it does and it shouldn't.
Mm.
But at that level, there are other tools that do that much better.
I see. Yeah.
You know, so the Netsage, so maybe that's one of the other lessons learned is we stayed really true to a higher level. Our main use case was large scale data transfers between sites. You know, so anything smaller than 10 meg we throw out. In part because there were a lot of tools that did the fine grain much better than we ever could. You know, but we didn't have anything that was showing us a pattern. So in general, how it's used in Anger is, you know, Netsage will show you a pattern, and then you dive down into your site-specific tool to find out exactly who's doing what in the you know, the 15-minute time frame that Netsage has told you to look at. So, all right. Well, thank you very much. I appreciate everybody coming this morning on a busy week, and I'm sure an earlier Friday than some of you would have wanted. This is going to get archived both, I think, on the TAC page and on the UT-OSPO page, which is opensource.ut.texas.edu. If people have ideas for other talks that they want to hear, please let us know. We're looking for other people to do these kind of case studies as well. Thank you very much.